Alrighty, so friction just complicates what we know a little bit. Not too bad. That friction always acts opposite to the direction of motion or attempted motion, right? And so what ends up happening is friction is a force. It will change the acceleration, how things accelerate. But the weird thing is that the direction of motion is typically referring to what? Not acceleration, but velocity, right? And so it will work against the velocity. We'll see that act in weird ways, and just put a star next to this, and whenever I mention that, just remember that's what I'm talking about. Friction depends on the what in contact? Surfaces in contact. And the coefficient of friction, mu, is the quantity that expresses the dependence of frictional forces of a particular surface, or surfaces, actually, the surfaces together that are in contact. Coefficients have a value between 0 and 1 typically. And if it's greater than 1, it does happen, but that would technically be probably an adhesive. So you can think about gluing something down or something being sticky. That would be outside our scope of this class, okay? So we have an equation that goes in this box that we're going to talk about the force of friction and how it equals mu times force normal. And that mu is code for coefficient of friction. So here's the problem right now, is that Mr. Kwan has noticed that sometimes he'll just say friction. Whenever I substitute in the word friction, I'm talking about the force of friction, and I should start to say force of friction. That's the long term of what I'm saying whenever I say friction, is force of friction. Whenever a problem gives you the coefficient of friction, it will say the coefficient of friction. What I really need to be underlining is just those nouns. Force versus the coefficient. That's the main topic. Of friction is just the adjective phrase, right? That describes that. It's like a preposition being used as an adjective or something like that. I don't remember English. But all that is to say is that when you read a problem, don't be looking for the word friction. Be looking for the word that we're trying to describe. Is it a force or is it a coefficient? And that is the first thing that I see kids mess up on all the time. And then we also have a normal force, okay? You'll also see it written as a lowercase f on some problems or as we go through some of our work. And that's because I might be describing the difference between static friction versus kinetic friction. And so if I've got the static friction, the only thing that has changed about our equation is that our mu corresponds to it. So if I'm talking about static friction, I'm probably going to be worried about a static coefficient. And same thing with kinetic. I probably need the value that is kinetic. Now let's talk about this value. The mu value, or the coefficient of friction, literally is just the stickiness of the surface, okay? So if you want to write that, that the mu coefficient of friction is the stickiness of the surface. So a mu of 0 is not sticky at all. What would we call that? No, frictionless. So it has no grip at all, frictionless. Oops. And then 1 is maximum friction, or what 1 really means is that for every Newton of force that I apply downward, I get out as friction. So things like car tires on concrete have a mu of about 1. That's important. That means for every Newton of force that I push side to side, can be counteracted by the fact that it's being pushed down, right? So if I push down by 100 pounds, I could push sideways by 100 pounds and not move it. Now, cars weigh about how many pounds does a car weigh? So about 2,000 to 4,000 pounds, depends on if you have a small car, big truck, right? Sounds about right? Okay, so if it weighs down 2,000 pounds, it's going to take about 2,000 pounds before the tires start to slip. 2,000 pounds of force. So whenever you make your tires spin out, that means you're applying more than 2,000 pounds to the wheels, to the surface and the concrete. Unless, of course, you change one of the surfaces. What has changed surfaces before? Ice. Yeah. So ice would have a very low mu value compared to your tires on concrete. And so they would slip. For 1,000 pounds pushing down,
only a few would go forward.
yeah, only a few would go forward or side to side. It wouldn't resist as much force side to side.
Basically like in the cartoons like Wile E. Coyote when he...
Yeah. Yeah. So what we really need to do now is switch out of pounds back to newtons. Same thing applies, except a car would be like 10,000 newtons now, right? But it's almost like a percentage is being reported back to the available friction. Okay? So that's what the mu value is. It's practically like a percentage value for how much friction you get out of how hard you're pushing down. If you have 0.5 for the mu value, then for every 100 newtons you push down, you get 50 newtons to before it starts to skid side to side. Okay? That's the general way of thinking about it. The other way that we talk about it is that mu will equal the ratio between friction and normal. That's the ratio that we're talking about, right? That's really what it is. It's a percentage of the source of our friction is the normal, the contact of the surfaces, and then the friction is side to side. And that's something interesting. This is a way that you're going to have a force up and down that interacts with your side to side. So if you change your up and down force, you're also going to change your side to side force. Force kinetic required to maintain motion is less than force static. So let me just write that equation wise. Fk is less than force static and must be overcome to start the object sliding over the surface. And so I always think about like moving a couch on carpet. If your couch has been sitting there for a while, it probably takes a little bit of work to get it to slide because why? The dents, yeah. So if it indents into the carpet, we have a little bit of trouble just to get it to move because it's dented into the carpet. Well, on the microscopic scale, that's kind of what happens when we have a static connection between the two surfaces. That it takes a little bit more to get it moving than to keep it moving. The static should typically be bigger than the kinetic. And so if that's true, this is mu k times force normal. And this is mu s times force normal. What do we see cancel out? Yeah. So I was like, no, it's mu because it's on both sides. No, force normal is on both sides. Mu has a different subscript. You're right. So mu k is always less than mu s, almost always. Sometimes they're pretty close. Just depends on the surface and how slick it actually is. Sometimes it's unreadable to be able to tell the difference. So that would be not an equals. We're not looking for an equation. We're looking for an inequality. That in this box would be that mu k is less than mu s. All right, we're going to start our samples.